Hello guys, welcome to my YouTube channel. Today I'm going to demonstrate how a RAG is being implemented, that is being made in LangChain and LangGraph. This RAG has a capability of optical character recognition, OCR. That means we can scan images, PDFs, and also we are using Tavily search just in case the sources of documents that we have is not enough. So I'll go ahead and just show you a demo of this project. So first of all, I'll start by running the backend. So it is loading the document. Then I'll come on this side and run the front end. So now that it is running, we can go ahead and just run it over here. So this is just the website, and then this is the chat application. So to show you, I'll ask it a question. What is the legal procedure to file a civil lawsuit? So let's wait for it to give us an answer. As we wait for it to give us an answer, we can go in the backend and see it is retrieving 20 documents, and then it is searching through all of them to give us an answer. So it got the answer. So let's see if it will show us here. Yeah. So here is the answer. It got it. So I'll go ahead and ask it another question. What are the rules for summary judgment for civil lawsuit? Let's wait for an answer. So again, it is searching through the documents to get us an answer. So let's see here. There it is. It got the answer. The rules for summary judgment in a civil lawsuit are primarily governed by Rule 56 of the Federal Rules of Civil Procedure. Here are the key points. So it gave us this answer. So let me explain to you how this program is made. We are building a RAG. A RAG constitutes of several parts. That is the document part where the documents are being loaded, and then this is the operation. We break them into small chunks of roughly 300 characters, and then it is embedded and then stored in a vector store. And then once a user gives us a question, we perform a semantic search. As you know, a vector store, the words and the words are attached to a vector and a numerical number, a vector number. And then once a user gives us a question, a semantic search is done in the vector store, and then the relevant documents are shared to the LLM, and then the LLM generates a better response for the user to see. So that is what has happened. So in our case, in case it doesn't do that, it will go ahead and search it over the web. So we have some links over there, and we also use Tavily search. I'll show you. So the configuration is made up of the following parts. We are using Tavily API, OpenAI, LangChain. Then this OpenAI, you need to subscribe to it. This is free. That is, Tavily search is free. And then these ones are also free. You can just go to the website, LangChain website, and get them. So I'll go ahead and show you the retriever part. So what happens here is that the first part constitutes of a web-based loader. That means we load the websites. That means the links that we have over there, as you can see. Yeah. And then the documents are loaded. That includes the pictures and the images we have over here. They're being loaded as part of the local storage we have here. And then we have the PDF loader. This one loads the PDF and also that performs, if in case the PDF has some images, This library will read throughout them and break down the words into small chunks and also store them. So the breaking part happens at this point. At this point here. Take the text splitter here, and then the embedding. We use OpenAI embedding. You can always use other sorts of embedding and store in your I'm using Facebook AI Similarity Search Index. You can use Pinecone, you can use Chrome, depending on what you want to use as your vector store. And then here is where they retrieve the documents. Our threshold is 60%. You can always make it 80% depending on your on what the number of documents you want to retrieve. It's up to you to decide. And then I'll show you here. We have our agent graph. Our graph is made up of nodes and edges. So our nodes are retriever, grader, search, and generator. So retriever, I've already shown you what is the retriever is. Grader determines whether we should use the local storage or the web base of the web. Okay. The search is the web part. Generator gives us the output. So I'll go to the nodes and show you the parts that I'm talking about. Here it is. The grader determines whether we should use the web or the local one. So we have the retrieve internal documents. And then here we have the grader that determines whether we will use the local or the web. And then this one gives us the web. Once it performs the search, it gives us the results over the other side. And then the generator gives us the output, depending on the sources that the documents that it was given. And then the prompt, here it is. This is the prompt that I have. As you know, everything must have a prompt, and then it always has a memory, and the memory that is being stored is here. So basically, this is just okay. Let me show you this last part. This is where we do the search over the web, and the maximum number of documents we have. The maximum number of search that we can perform is, in my case, I think is 10. Yeah. This one represents the number of clusters. So yeah, thank you. I hope I'll share this code and the link for this code in my bio. Thank you guys.